Okay, so this is a video showing how to transfer file from Revit to Robot in 2023 versions. First, I've opened Revit 2023 and I'm going to create a new file. When you transfer into Robot, always structural template. Always use structural template. And make sure you have all the UK libraries installed if it's on your computer, because you will need various UK sections for this video. Now, first of all, let me show you the example. So this will be a steel frame building, single-story steel frame building with a 200 millimeter thick concrete floor, C35, loaded with 3 kN per meter square live load, and obviously it's self-weight of elements. And it has 4 bays, 9 and 6 meters are the lengths, and these are the sections for primary, secondary beams and columns, and this is the 3D view showing the live load on the floor, and this is elevation showing that the height is 4 meters. So after transferring in Robot, you need to create the ultimate limit state load combination based on Eurocode, and then also set all floor slabs as one-way slabs, and all beams and columns is simply supported. And do the analysis in Robot to find bending moment diagrams on beams and shear force, displacement, normal stress, shear stress diagram, and also the axial force in the central columns. So this is the task, and I'll first in Revit go to the elevation view, any elevation view, and change this to 4 meters. And click twice to exit. And now going to level 1. Quickly do the grid lines. So first the vertical ones, and then I can do it quickly maybe. And another one also at 6 meters. Escape. Okay, and now the horizontal ones. I'll press escape twice just to change this to grid A. And then the next grid will be at 9 meters distance. Okay, so these are our grid lines. So we have levels and grid lines done. Now I'm in level 1. I can now do the columns next. So if you look, the correct column is not here, which is 203 by 100 UKC. So I can load the family, and you need to have UK libraries installed, which are separately installed in then the Revit program. And we need structural columns. Library, steel, Chorus Advance, and UKC. And we need 203, 100. Okay, so this is now added to your program, to your project file. And if I put here the height height is to level 2. You don't have to do it now, you can just adjust it later, but might as well do it now. And then at grids, if you go from right to left, then the overlap mode is for selection, and finish. And just check in 3D view that you have, yeah, they're fine, they're going up to level 2. Steel columns of this cross section. So I can go back, so I can go now to level 2, and in level 2 I can do the beams, and again, if I look, I don't have the correct beam sections, so I can load family. And now I am here already, but if I look here, this was in structure columns, so if I select straight away the beams, it won't work. I need to be in the correct category. So I need to go up to the UK and then make sure I choose structural framing. Steel, chorus, and UKB. And I need to now load 406 178 67. Okay, and it's showing. I should also load the secondary beam section, and it's the same UKB. Now I am in framing already, so I don't have to check anything else. And the section is 254 146 31. So I can see both the sections that I need for this frame are loaded, and the correct beam is selected for the primary beam. And now to place the primary beam, I can choose on grids, select the grids, and finish. So very easy to do this. Now I'm done now with beams and columns. So check again in 3D view. Yeah, it's perfect. And now I can go to the go to level 2 now again to place the secondary beams. The secondary beams can be done as beam systems, automatic beam system, and we may or may not choose to put a tag. It's not very important for this exercise to put a tag. And make sure you choose the correct beam type, which is loaded here, correct one. So that's why we need to load it, because otherwise it wouldn't be appearing here. Change this to maximum spacing, because if you leave it as exact spacing, they won't be equally spaced, and we want them to be at 3 meters. Tag style, we could have, if you could select tag on placement, you can choose the tag style framing, but we don't need that. And now, if I hover by the primary beam in the horizontal direction, I can place these. So these are also beams done. And the last, well, not quite last, one more thing is the floor. Floor is slab. Oh, not slab, sorry, slab. This is in foundations. I'm looking at the floor. Floor says here generic 300 millimeters. Now we can't load the exact floor like we did for steel framing, but we can edit this. So we can duplicate this type of floor and just give it a name RC 200. And we can even put C35 to be very prescriptive. Yeah. And now we need to edit the structure as well. So in the by category, we go and change it to C35. And thickness to 200. Okay. Okay, so we created now the correct type for our floor, and we need to place it, and we can place it using the supports. So these are walls or beams, so we can use this. Select our beams. We can choose the offset, but we don't need any offset. We can do the height offset by the floor thickness, which is 200. And this is important to do. Span direction. This is two short lines show that the slab is currently spanning in the east-west, but we want it to span in the shorter direction, which is 3 meters north-south. So if I go to span direction and just click on the vertical one, it will change it. So this is essential to do, really, if you're going to do analysis of slabs as one-way slabs. And that's it. We can accept, and our floor is created. Now, in 3D view, I can't see it because it's not showing. Yes, so this is now our structure, and I'll just put also the foundations because it's easier to do it in Revit than later on in Robot in many cases. Now, for foundation, I need to be in level 1 and just put isolated foundations. This is fine. Don't have to change the type or anything. Yes, I don't know if this is necessary, but I'll just change the concrete to C35, and then add columns, select all columns, and these are our foundations, and finish. Okay, so in terms of the structure, we have done everything. Now we need to create the loads, also in Revit, but in prior version that was possible because analytical model was automatically created, but now there's no analytical model and there is no way to put loads on something that doesn't exist. So you can only put loads of analytical model. So now I need to create this analytical model the way it is done in the version 2023. And the easiest way is to go to Analyze and click on this tool, which is Analytical Automation. So automates the creation of the analytical model. The reason that this has been done in new version of Revit is to improve flexibility and adaptability of these analytical models. But yes, it's a little bit different procedure than in previous versions. So what we need to do, yes, just click on the physical to analytical for buildings. It was a good idea to save the file first, which I haven't done. Oops. Okay, so it says generate, so you need to select physical elements, and I will click on select and then select in Revit, and I'll just drag to select everything, including the grids and levels. And select. Oops. What have I done? So I already selected that, and it's already showing that it's selected, yeah. Now, this is important because this is a tolerance between analytical elements, and it will join all the elements which are within the distance. And this is set in projects unit. If you remember, when we inputted lengths, these are in millimeters because it was 6,000 and 9,000. So we must change it to millimeters. Let's say 350. I mean, you can change to what you think is appropriate, but this should be fine. 500. And then we don't have any walls, so let's put a column as the first, then the beam, and then the floor. So that's what takes priority. And now we can run. And with some luck, we will get our run complete, okay? It's showing these members that were created, but we really need to see it on the analytical model. This is a previous one. Yeah, so this is our analytical model. Now it looks correct. These are beams, columns, and there is one panel. And now we can go to analyze and add the loads here. So the load is, we need hosted area load, and we need live load, because that load will be automatically added as self-weight. So this is hosted area load, which means on the whole panel it will be applied, and it should be -3. Sorry, my mouse moved. And I exited, sorry. So again, analyze, load, and this is -3, and apply. Oh, sorry. Select and then it will apply. So this is applied the load on the whole floor, and that's all done. I will now save the file, definitely. I'll save it as steel frame, maybe. And I'll call it 23. And now let's see if it transfers well to Robot. So I'll open Robot. I don't need to open any files, just to start the program. So I don't need to do anything else. Now in Revit, I'm going to go to the Analyze menu and Robot Structural Analysis link. And yeah, just send model. So it takes a few moments, and if I go to Robot, it's appeared, yeah, so it's here. Okay, so that looks correct. In Revit, it's saying we want to see events report. I don't really. Okay, so this is our analytical model now.